Welcome back to System Design course. Today we are at part 2.1 and we are discussing the basics of networking. Every time you load a web page, send a message or stream a video, data travels across networks. But how does it actually move? To understand that, we use the OSI model. It means Open Systems Interconnect model, a layered framework that breaks down into communication into 7 steps. Each layer has a job. Together, they make the internet work. For system designs, we focus mostly on 3 layers layer 3, network layer, transport layer, and application layer. But let's walk through all the 7 for clarity. Let's start with physical layer. Physical layer transmits raw bits over physical media, like deals with cables, fiber optics, radio signals, voltage levels, etc. For example, you can just think it's the road the data travels on, actually wires or signals. For suppose you have a system here and you have a system here, it only deals with the raw bits, like with it, it's like in the value something like this. For examples, for this one, like Ethernet cables, Wi-Fi signals, and Bluetooth. Without physical transmission, like no data moves. This layer defines the speed, range, and reliability of the connection. Coming to the second layer, data link layer. Here in this layer, it deals with the packages bits into the frames. Like we got this one, right? It will just package that, it wrap all this data into the packages, handles the MAC addressing and error detection, ensures data moves correctly between devices on the same network. For example, it likes labeling packages with sender and receiver information inside a building. For suppose there is a building and you have an email address with the receiver and sender address like within the same building. So if you are in room 101 and you need to send the mail to room 201, if you have that information in this building, like you can send it, right? Like yeah, but the data inside that mail is called the raw bits. So it will just wrap up that and it will send as the MAC addressing like that. And coming to the layer 3, it's called network layer. It handles the routing and addressing across the network, moves packets from one network to another network, and it uses the IP, Internet Protocol. For example, it's the GPS system, figuring out how to get data from your device to serve across the world. For these examples, we have IP, routers, and ICMP. Responsibilities like assign IP addresses and route packets across the routers. And why it matters. This layer connects different networks and ensures data reaches the correct destination. Coming to one, this is the most important layer, like one of the important layer we're going to discuss. One is the network layer. For suppose you have your system here and you have the system here. So to connect that, like you need some IP addresses. For system, like you have something 101 IP address, and for suppose this is the 20.01 IP address. Without knowing the exact address, like in the internet, like it can't send right the data. So with the network, like you will have the IP address of every system. So it knows like how it can connect to the internet and it can search for the right address in the across the internet and it will deliver to that. So this is called the network layer. And next coming to the transport layer. It manages the end-to-end communication. Like it ensures reliable or fast delivery. Like it uses the TCP, UDP or quick models. For example, and this is the second called the transport layer. It is the second most important in the system design. For example, imagine it's like a delivery truck, deciding whether to guarantee delivery or send it quickly without the confirmation. For suppose yeah, you have to send data from here to here. So you have two options like the TCP and UDP. So what it will do is TCP, it will send the data from here to here. For suppose the data, as I said, like you have the bits first and it is going to wrap up like a packets from here, right? So you will have something like this. The data will be like these packets. But suppose it doesn't, like I'm like let's I'm dealing with the TCP for now. This is how TCP works. For suppose it should not to be in a order. Like for suppose the order is 3, 2, 1, 4, and we already sent the data to here, and it also receives like something like 3, 2, 1, 4. So every packet have the ID. So how the TCP works is like it will send the data to here, and it will scan like it will scan every packet and the encrypt the data, and also made it in the right sequence like 1, 2, 3, and 4. So this is how the TCP works. And coming to the UDP is for like quick with like it won't do the search as something like the magnet, like it won't do the search of every packet. It will just send all the data at once. For suppose it only receives three packets like 2, 1, 4, and the third packet is lost. So it ignores that packet, like it doesn't care about that, like it only take the three packets. It is called about the UDP. And before that, like I just want to tell the responsibilities of this one. Like it just open and the close connections, and it handles the retransmission and acknowledgements. And really why it matters, this layer decides like how data is delivered, like reliable or quickly, depending on the use case. And coming to the next one is called session layer. It manages sessions between applications. It also handles start, maintenance, and termination of the connections. For example, like it's like a phone call, like you dial, you talk, and hang up. The session layer manages that life cycle, something like the TLS. So I will give a small overview about the handshake, like how it works in the communication. Like the TLS handshake, like for suppose it will be for suppose I'm explaining the three-way handshake. This is the two computers, right? At first, like it will sense the data. I mean, it will sense the connection. Then this one gives a response, like yeah, I got the response. So once it receives the response, like then it going to make a stable connection. Means like yeah, this system got to know this system is exactly here, and it was connected. So here, like it is going to send the transform the data between those. After that, once the data is completed, if something happens in between and the session is broken, it again will going to connect. So all this going to happen at the session layer. So it keeps track of conversation between systems, especially for secure or stateful communication. And coming to the next layer, presentation layer translates data formats and handles encryption or compression. So it likes translating language, like making sure both sides understand the message. So examples like JSON, XML, and it also deals with the encryption of SSL or TLS. So why this really matters? So this layer ensures data is readable and secure, especially for APIs and web apps. So as of now, like we got the bits and it was the packaged in the data format, right? Like, but we don't understand, right? So it's what going to do is like as of now we have it in the bits and packets. So this is going to convert into something like human understandable language called JSON or XML, something like that. So this is layer for the transcription and encryption. In system design, and one another more important layer is called application layer. For example, like it's the spoken language between apps, the actual connect of the message between these two systems. And examples for this one, HTTP, HTTPS, REST, GraphQL, gRPC, WebSockets. We have so many like SMTP. We are going to discuss in our future courses. And coming to the responsibilities of these things are called like it formats requests and responses and define endpoints and methods and handles authentication headers and cookies. Why it really matters? Like this is where developers interact, designing APIs, sending requests, and building user facing systems. So usually this is the most important layer where users can see. Generally, users can only connect with this layer in the application layer with the using some user interface. And by using this user interface only, we are going to pass the data between the systems, and this is all workers under the hood between these behind this layer. So for example, like I will explain everything in your flow. For suppose you have a system here, and you want to send data to this system. So how it will works means, for suppose you have a data. For suppose you have a data. So what happens is, once the data is there, like it was in the human language first, right? For suppose you have something called hi here. So what it will do is it will transmit the data into something called, it will encode into something like 101 word, something like that. And coming to the here, like it will have the HTTP header as of now here. So for this hi message, like you have the HTTP header, and it will just transmit the hi to something called encoding, and it will do the connection. As I said, it will just make the connection, and the data looks something like this, something like 1011, and HTTP header we have here. And coming to here, it will add the TCP header through this one. So it will add the TCP header. So as I said, like it will depends on the use case, you are going to select the TCP or UDP, and it will use the HTTP here, and it will have the same address. And coming to the IP address, it will add the IP address to this one, IP header here, and you will have TCP, and you will have HTTP, and you will have 1011, something like this. And it will add the MAC header to on top of this one. Here the MAC, IP, TCP, HTTP, and 1011 here. To make it clear, I'm writing here. And finally, this is the bits. Like this is how it will have the bits, and we'll have all these layers here. So everything. So what happens is, whenever you want to send hi message from here to here, so first it will just get here, and after that it will add the HTTP header, and after that it will choose the connection, and after that it choose the TCP or UDP or QUIC based on your use case, and after that it will do the IP routes. After that it will add the MAC addressing header, and after that it will do the bits. After that it will do the here like this, like this, like this, like this, like this, and finally it will get the hi address to this one. So once you want to do a send address, send the message, this is the process it will take. And if you want to receive a message, it will do all these steps from this system. So this is how the hi is going to send from here to here. So this is how it works. Every time you send a message or load a page, all the layers going to work under the hood. This is how it works with the OSI model. And coming to that, like layer 7 formats the request, and layer 6 encrypts it, and layer 5 manages the session, and layer 4 decides how to deliver it. Layer 3 routes it across networks, and layer 2 frames it, and layer 1 sends it like a electrical signals or radio waves. So final thought, like understanding the OSI model helps you reason about every part of the system communication, from like physical cables to the, like from here, like from physical cables to the API here. And as we move forward in this course, like we will explore how these layers shape load balancing, transfer protocols, and global delivery. We are going to discuss in our upcoming sessions.